All right. I think it's recording. So you guys needed graphic organizer number 2, 4.3 graphing proportional relationships. Now, those 3 words, graphing, proportional, and relationships. What does graphing mean? We know what that means, right? What is it?
On the chart.
Okay, plotting points makes a line, right? Easy. Proportional. We've used that word for other things, right?
Like even.
Yeah, proportional just means like not distorted, right? If I had a picture of a dog and I drug it by the corner to make it bigger, it would grow proportionally, right? If I moved it in from the side, it would shrink it and go whah, and it would be ugly, yes?
Yes.
All skinny and
Would be
distorted. Yes, it'd be very distorted. So we know what proportional means, yes?
Yeah.
Yes.
Okay, relationships. Now I'm not talking like boyfriend, girlfriend, kissy, 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 held hands. I'm talking about how something affects something else, right? The relationship between x and y on a coordinate grid is x means left or right, y means up or down, right? Okay, at the bottom of this page down here, where you see you have some extra space, I want you to write the words direct variation. I'm going to give you a definition for direct variation, and let me tell you, when you read it, it's not going to make much sense to you. But I'm going to break it down so it makes complete sense, okay? Direct variation. Now, don't highlight while writing it. Write it all down, then highlight how I did, same colors and everything, okay? Okay, so I'm going to go ahead and get rid of this box so you guys can see the definition. Ready? Direct variation. I'll read it out loud. If x and y are proportional, then, comma, the relationship can be represented by the direct variation equation y equals mx, where m is the constant of proportionality. The graph of y equals mx is a line with a slope of m that passes through the origin. Okay, I'll let you guys write that down. I'll try to give you enough time. If you're watching this video, then you can fast forward. Once you have that written, go ahead and use the highlighters to highlight how I did, okay? It's a lot of weird information, right? Okay, so it looks like some of you guys are just about done writing the paragraph. Make sure you grab a highlighter and highlight the things.
So.
Direct variation, like the word, is yellow, and then y equals mx is also yellow. Then I've got m is the constant. That's green. And then I've got passes through the origin is orange. Now, as the last class learned, this was really intimidating. Like when your teacher gives you that definition right there, your first thought is, uh-oh, this section is gonna be horrible. I'm not gonna do well. But that's actually not the case. This is a very easy section with a very convoluted way of explaining it, okay? So what I'm going to do is I'm going to try to teach you what this definition is saying, and I'll give you examples, and you'll just go, oh, that's it? This is easy, okay? Yes?
Is it any way related to y equals mx plus b?
Totally. Yep.
And is that why it's y?
Yeah, that makes sense.
Hey, let's okay, now that you guys are kind of done writing it, and almost everybody's done writing it, I'm gonna read this out loud to you now. I'm gonna read it out loud. And I want you guys to just really focus on the words that are highlighted mostly, okay? Ready? Direct variation. If x and y are proportional, then the relationship could be represented by a direct variation equation y equals mx. I'm going to freeze there for a second. What does that look like?
Something is being represented by something.
Here's what I'm asking. What does this look like?
It looks like something.
Ian said, it looks like y equals mx plus b, but who's missing?
The b.
The plus b. Now, what is b?
The y-intercept.
The y-intercept. And now, back in our previous notes, way back here, holy smokes, if there is no b, like this, if there is no y-intercept, then the y-intercept is what?
0.
Right, guys? Does this look like y equals mx?
Yes.
Does this look like y equals mx?
Yes.
Okay, so what are you noticing about both of their graphs?
They cross through the origin.
Uh-huh. So guess what? Over here in the notes that you wrote,
It's basically just y equals mx plus b, just you don't ever have the y-intercept, and it's just...
you do have a y-intercept. You do.
It's...
What is the y-intercept?
The origin.
0, right? Isn't that why we highlighted in orange right here? It passes through the origin.
Mm-hmm.
If there's no y-intercept, there actually is a y-intercept. It's 0, which means you put a dot at 0, right? Okay, look at the green. M is the constant. What does the word constant mean? If I say you're constantly being annoyed,
Doesn't it change?
it means continuously, doesn't change, the same always, right? What is M? M is the constant. What's M? Slope? Yes? M is slope. This sentence right here, M is the constant.
So the
That
slope
says
never changes,
M.
the slope never changes.
Slope never changes, okay? So in this big confusing explanation right here, there's some key points to understand. Ready? Direct variation can be represented by this equation. Okay? Something else. M, which is slope, will always be constant if it's a direct variation. And I know all direct variation lines go through the...
The origin.
Yes. Okay, that was a lot of information. Like I said, it'll make sense when I give you examples. Okay, you ready?
Yes.
Okay, now, on your graphic organizer in the center, please write this. Y equals mx. Remember, you're going to have to use your nice little handwriting. Y equals mx. How to find m without graphing? What is m again?
The slope.
Yeah. M is slope. Direct variation is going to be asked in a lot of different ways. So I will give you some examples of how they'll ask it, and I'll give you examples of like what they're looking for, okay? I know right now you guys are probably thinking, I have no idea what Ms. Ringler is talking about. This is the weirdest lesson ever. But here is what a question would look like if it's dealing with direct variation, okay? Go ahead and write this down in the first box. The coordinate 6, 3 is a part of a direct variation. That's what your book or your test would look like, okay? Your book, a quiz, a test, it would ask a question like this, okay? 6, 3. What is this?
Rise over Rome.
No, that's not a slope.
That's a coordinate.
That's a coordinate. That's a
Oh,
dot
that's
on the
right.
graph, right? 6, 3 is a part of a direct variation. What? Here's the question. What is the slope?
Oh, I get it. So you just you kind of simplify that equation, and that's the slope. I mean, you just simplify
Close.
that coordinate into a fraction.
Yeah.
It was.
Essentially, you're going to in a second. I'll show you guys how to do that. But Guys, if I said to plot that point, don't draw this. Did you guys hear that?
Yeah.
Don't draw this. I'm just going to show it to you real quick on here. If I said plot the point 6, 3, wouldn't you go over 6, up 3?
Yeah.
So it'd be over here. If I said, what's the slope of that? A lot of kids would say, Mr. Engler, that's a dot. Slopes are with lines, not dots. And I 100% agree.
Back 6, down 3?
No,
Or
that's a dot, right? That's not slope. This is not slope. That's a coordinate. That's a dot. If I said, what's the slope of that? That's not anything that has slope. It's a dot. Agreed? Lines have slope. However, because the direction told us that it's a part of a direct variation, that means I know that the line goes through the...
origin.
Okay, so if it goes through the origin, isn't that another point?
Oh.
Now can I connect 2 dots with a line?
Yes.
Oh. Oh ho ho ho. So because it's a direct variation, it goes through the
Origin.
origin. Now hold on. Remember I said don't draw that little grid? Yes?
Yeah.
Okay. Because what did I say in this little circle that we're doing?
How to find out without graphing?
Did I just graph?
Yeah.
Could I have... Okay, let me undo for a second.
You're doing a
Could I find slope from this?
Yeah.
Yeah, I go up 3 over 6.
Yeah.
Ta-da. But guess what? I said we're going to do it without...
Without
Graphing.
graphing.
So here's how you do it. If I didn't say there's no grids, nothing, right? And I said 6, 3 is a part of a direct variation. What's the slope? Hey, what is the equation that I said is a part of direct variation? Y equals... Okay, write that down. Y equals mx. No b, because what's b?
Intercept.
And we don't, it's 0.
It's 0.
Hey, I'm going to ask it again. You have the right answer. Ready? Hey, guys, there's no b. What is b?
Intercept.
It's 0. We don't put plus 0. That's redundant, right? We don't need it.
Yeah.
Okay, now, looking at 6, comma 3, which one's the x and which one's the y?
The first one is X.
Go ahead and small, write that underneath there, xy. Nice and small.
And then do we plug it into the Y and the X?
Yes. Oh ho ho. Guys, plug in the 3 for the y and plug in the 6 for the x.
U equals M6.
Uh-huh. How do I get m by itself?
Divide.
By?
6.
To both sides?
Yeah.
Okay, now m equals 3, 6. Can I reduce that?
Mhm.
To what?
1 over 2.
One.
I mean 2.
Yeah.
1 over 2.
It's a half, right?
That's your slope.
Yeah, guys, what is m?
It's a half.
Slope. Slope is
Is M.
1/2.
Wait.
Okay, let's review real quick.
Oh, I see. Okay.
The question said 6/3, sorry, not 6/3, 6, comma 3 is a part of a direct variation. That's our key that it's going to go through the origin. What is the slope? I know it's a direct variation, which means I need this equation, correct? Yes? Okay. I know that that's an x and that's a y. Just pop those 2 things in for x and y. Get m by itself because m is slope, right? Once you have m by itself, you have found what m is, and m is slope. You did it. You found slope. Yes.
Could you just see that as a fraction and
Totally.
simplify it?
I want you to remind me of that in a second when we get down to this box, okay?
Okay.
So you keep that in the back of your mind and remind me, okay, Riley?
Okay.
Okay, do this next one. 105, comma 15. And this is another way that the question might be asked. It says, they are directly proportional. They are directly proportional. Find the slope. Okay, once again, if it says that they are directly proportional, didn't my definition say that direct variations are proportional? Yes? Which means what equation will I be using?
Y equals MX.
Y equals MX.
Why no plus b?
Because B equals 0.
Which means it's a direct variation that goes through the...
The origin.
Origin.
Ta-da! Now guys, remember, the next thing is, tell me who's y and who's x.
X is the first one.
Yes?
Y is the second one.
And now plug them in. My equation should look like this. 15 equals m times 105. How do I get m by itself? By dividing 105?
And then you get 15 over 105.
Can I reduce that?
Yeah.
3 over 36.
What did you want to take out of both of these? A 5?
No. 1 over 13.
Okay, let's do 3 over 36 first, okay?
Yeah. 3.
Is it 36? 36 times 5 is 105?
Yeah.
Should I take your word for that? I think
I think you should.
I don't think so because 6 times 5 is 30, and I need it to end in a 5.
Yeah.
Oh, oops. It's 37. It's 37.
37 times 5?
Yeah. So
Okay, switch it out. Okay, 7 times 5 is 35, 15, 16, 17, 18. That's 185. We need to go a lot lower.
27.
yeah.
I can't remember what it is. I think it's something like, let's just try 17. Let's try 17 times 5. 7 times 5 is 35,
It's 13.
5, 6, 7, 8.
No, because then that would be even less.
Okay, we got to go higher.
It's
19, maybe.
Should we try 19?
Yeah.
19 times 5 is 45. 5, 6, 7, 8, 9. Ooh, we're so close.
Try 20. Try 23.
So how many more 5s do I need?
21.
25.
Don't I just need 2 more 5s?
Try 21.
So wouldn't that be 19, 20, 21?
God.
Okay, so my answer is,
It's okay, Riley. You got close.
okay. Can I reduce that?
Yeah. Do
Yes. 1 over 7.
1 over 7.
Did you saying take out a 3?
Yeah.
Okay, holy moly, that was a lot of work just to say what? Slope equals,
1 over 7.
woofda.
That's kind of easy.
It is, because honestly, all I'm doing is I got a point, yes? I'm putting that point in for the x and the y, and then I'm finding what? Slope. Now, right now, that feels really useless, I understand. I will give you example problems of when we would use that in your actual math, okay? For example,
So there are some times that we wouldn't use it.
no, this is like the steps to know how to use it, right? So I'll give you an example of that. Before I do that, though, in this box is going to be like your main idea. Ready? Direct variation. Direct variation is the same as a proportional relationship, which is the same as y equals mx. Would you guys all agree with that? Those 3 things are the same thing. I think that's why this lesson gets so confusing, is because it uses all these different words, equations, and thoughts for just one single thing. All of this is direct variation, right? Direct variation is a proportional relationship. It is y equals mx. And guess what? Direct variation, the main idea is that it just goes through the origin. Okay?
That's simple.
Direct variation, proportional relationships, y equals mx. That's all the same thing. All it means is that it goes through the origin. Okay? All of those go through the origin. Sure.
That's like ridiculously easy, but it sounds hard.
It sounds hard, and it's a lot of like confusing words just to mean the same thing, that it goes through the
Origin.
yeah. Now, in this next box, this is where I'm going to show you how you would use this in your actual math, okay? Before I do that, though, I'm going to go ahead and get the book open real quick. Okay, I'll go back to this so you guys can finish this, okay? Direct variation, proportional relationships, y equals mx, it all means the same thing. It just means they go through the origin. You have a question? Sure. Here we go. Ready? Look at the graph number 3. Is that a direct variation?
No.
How do you know?
It starts
It
at
does
5.
not cross the origin.
Yeah. Guys, it's that simple. Is that a direct variation?
No.
No. You don't even have to do math. You just have to look at it. Is that a direct variation?
Yes.
Because?
It goes to the origin.
How simple is that?
Easy.
Easy peasy lemon squeezy. Now if I said, is this a direct variation?
How
Well-
do you have to graph it?
Well, let's talk about that. go ahead and in this extra box down here, I want you to draw me that little chart that we just looked at, just like that, okay? I've got X, Y, 3, 6, 9, 12, 1, 2, 3, 4, and underneath it, I want you to write the question, is this a direct variation? Guys, X and Y right here, these are coordinates.
Yeah.
They're just put into a table.
So just
For example,
plot them?
what's the first coordinate a part of this table?
3.
No, we're not talking slope. A coordinate is X comma Y in
That's-
parentheses, right?
Yeah.
So what is the first coordinate?
3, 1,
3 comma 1. So go ahead and write 3 comma 1. That's the first coordinate they gave us in the table. What's the next coordinate?
6, 2.
Okay. Go ahead and list them all for me. Got 9 comma 3, yes.
With, if you look at it, the slope is 1 over
Yes.
3. And
We'll talk
then-
about that in a second, please, okay? Hold your thought. That's what I told Riley to do, is hold that thought, okay?
First time, Ian.
The first time being big run.
Okay. My question is this a direct variation? Now, what you guys noticed in these two example problems, when you were given a coordinate, you needed to find the...
Slope.
Okay, we'll try that again. There's how many of you in here?
Slope.
Guys, when you were given a coordinate, what did you have to find?
Slope.
Each time, correct?
Yep.
Now, how does finding slope tell me if it's a direct variation? Well, come down here to the little definition I had you write at the beginning of the class. Okay, what does the green part say?
M is a constant.
M is a constant of proportionality. What that means is if I find the slope for each of these, and if the slope is the same for each of these, that means the slope was constant. If the slope is constant, is it a direct variation? Yes. So how do I find the slope for each of these? Well, we up here plugged it in for x comma or y equals mx, right? However, I had 2 students notice something while we were doing these example problems, and I wonder if you guys noticed it too. Let's look at the first example problem real quick. The point 6 comma 3, what ended up being my fraction?
3, 6.
I mean, yeah, before I reduced it, right?
Yeah.
We're not talking after the reducing. We're talking before the reducing. It was 3, 6. Isn't that the y over the x?
Yes.
Okay, let's look over here and make sure it's the same thing. We had 15 over 105. Isn't the y over the x?
Yeah.
So here's a little shortcut. Instead of plugging it in and doing all this math right here, can't you just tell me it's the y over the x? Okay, so over here, I want you to kind of like give me a little bubble and say like, psst, like this is like a little like secret, yes? Here's a secret, psst. The slope is just the y coordinate over the x coordinate, yes? Isn't that a nice little secret? Which means, do I have to go and plug everything in, do the math, divide by things? Or do I just like look at it?
Redux.
It's just the y over the x, right? Who's the y in 3 comma 1?
1.
Who's the x?
3.
What's the slope? Yeah, you did it. Hey guys, what is the y?
2,
Who's the x?
6.
Can I reduce that?
Rise over run.
What does it equal? 1/3? Okay, what is the y and what is the x?
3 is the y.
Which is equal to?
1/3.
And what about the last one?
1/3.
It'd be 4 over 12, which is equal to? Okay. If all of my points have the same slope. Yay! Guys, if the points all have the same slope, you know what that means?
Direct variation.
Yes, it means that if I had a grid right now, all of those points would land on the same line, and that line would go through the How awesome is that? So my final answer to this question, is this a direct variation?
Yes.
Yes, because what?
It
All the points
goes
go through the
all
line.
the way.
You could just say yes because they all have the same. Yep.
You could also do since the last coordinate is 3, 1. You could just subtract the y from the y to get 0, and then 3 to get 0 again.
So you're finding the slope of from 2 points, right?
Yeah.
When we did y2 minus y1 over x2 minus x1? Totally.
I figured out.
You're going to want to remember that because you can use that in like 3 or 4 sections from now, okay? Man, that's big brain thinking there, Ian. Pretty awesome. Okay, guys, that was a whole lot of information coming your way, but if you think about the main idea today, is it kind of easy?
Yes.
All I'm asking and telling you is that if something is a direct variation or a proportional relationship, or if you use y equals mx, it's going to go through the,
Origin.
and all the points will have the same.
Slope.
Yeah, how easy is that?
Yeah.
Yeah, okay, so here. You don't have to write this one down. But, is this a direct variation? Well, how did we do that in our example? First we said we got a point. We got 2 comma 4, right? You guys told me the slope is the y over the x, so it's 4 over 2.
Yeah.
What does that reduce to? 2?
Yeah.
Okay. How about the next point? I've got 5 comma 8. That would be 8 over 5. Does that reduce to 2?
Yeah. No, it doesn't. because
Ew.
It's 5.
It does not. So hold on. Do I even have to go check the rest?
No.
No.
No, because do these first 2 have the same slope?
No.
No. So is this a direct variation?
No.
No.
It's not.
How simple is that, guys?
E.
That's literally, the whole chapter is very confusing, but it's all because that's all they want to know, okay? Now, number 10. I want to show you something. This is the homework section of this lesson. Not saying we're doing it, but I want you to notice something about it. Did you notice that 3, 4, 5, and 6 are the only problems that are not a story problem?
Oh my.
Right?
I remember last year when
So-
we would just have like.
What do you think direct variation is useful for? Which is like real life, right? Direct variation is something that a lot of people use in real life. They use this in business. They use this in basically anything that you have to find a proportional relationship with. Okay? For example, if I said I'm a marine biologist, actually that'd be more dealing with like oceanic creatures. How about I'm just like a wildlife biologist, and I am reintroducing a certain type of frog into this pond so that it can eat the fish that are not supposed to be there. Right? Does that make sense to you?
Yes.
Would there be a direct proportional relationship for how many frogs I enter versus how many fish disappear?
Yes.
Because like let's say one frog, these like special frogs, can only eat like maybe 3 fish a day. So if I enter in 2 frogs to the pond, how many fish are going to eat in that day?
6.
If I enter in 3 frogs, how many fish are going to eat in that day?
And they have to repopulate at the same speed. The fish have to repopulate at the same speed.
So my question though is that a direct variation?
Yes.
Every time I add a frog, do 2 fish disappear? Every single time?
Might need to add more frogs.
Well, hold on, Riley, don't interrupt my thoughts, please. Okay? Another direct variation could be money, right? If I want to make t-shirts, I know a t-shirt costs $10, right? And then I know that like putting on the extra like logo or something is gonna be an extra $2 with it. A direct variation would be it's gonna be $10 plus 2 every single time I make that shirt, right? Will my expenses grow depending on how many shirts I create? Right? Let's do this example together. Toenails, how great is that?
Delicious.
Yummy. Let's talk about toenails.
Tummy.
Toenails grow about 13 millimeters per year.
That's not that much.
The table shows fingernail growth. For example, week number 1, how long did the fingernail grow?
0.7.
Had week number 2,
Millimeters.
1.4.
week number 3,
2.1.
and week number 4.
2.8.
Okay. The question says, do fingernails or toenails grow faster? Explain. So remember, this is two different sets of information. It says a toenail grows 13 millimeters per year. A fingernail, it looks like it's growing bi-weekly. Do you see that?
Way faster.
Do you think maybe I need to see how much a fingernail grows per week?
Yeah.
What does it grow per week?
It grows
Point
0.7.
7.
Is it 0.7 plus 0.7 every time?
Yes.
Yeah.
So is this a direct variation, just this table?
Yes.
A direct variation because it's a proportional relationship, right? So could I say toenails, I'll put TN for toenails.
They grow way slower.
Toenails is 13 millimeters per 1 year. Fingernails is 0.7 millimeters per 1 week. Can I compare the two unless they're in the same format?
Yes, you can.
Well, I'm comparing years and weeks.
So you just gotta do like.
Can I turn that
Yeah,
weeks
weeks.
into years?
They're
Hey, Rachel's
52
table.
weeks.
Rachel's table. Guess what? Nobody's looking at me. All three of you have your eyes elsewhere. Look up here. We're talking about toenails and fingernails. We can't get more interesting than that. Disgusting. Okay, look. A toenail grows 13 millimeters a year. A fingernail can grow 0.7 millimeters in a week. I need to change this to year before I can compare them. Okay? How many weeks are in a year?
Just divide 365 by 7
No.
51 or 52.
to find how
I
many
think there's
weeks there are.
52 weeks. Yep, 52 weeks in a year. I think that's just information you have to know.
52 times 0.7.
Okay, what is 52 times 0.7? Guys, that's really simple math you don't need a calculator for. Look, 52 times 0.7. What's 7 times 2?
14.
What's 7 times 5?
35.
Plus 1?
36.
How many decimal places?
1.
Okay, so now I know fingernails actually grow 36.4 millimeters per 1 year. Which one grows faster? Fingernails. Interesting. In the same coordinate plane, could you graph that equation that represents the growth of toenails and fingernails? Compare the steepness of the graphs, and what would it mean in the context of the problem? Now, I have a question. If I were to graph this, right? I'm still up here, dude. I didn't go anywhere else. If I were to graph this, you just told me who is growing faster? Fingernails. If fingernails are growing faster, would their line
Go
be
smaller.
steeper or less steep than the toenail growth?
Steeper. Because they're going up higher.
Yeah. I think I've only got like 2 or 3 who were listening though. Okay? Gotta wake up, guys. You gotta show me you're paying attention. I can't have one person answering the whole time. I gotta have however many there are in here answering. Yes? Sit up tall. Thank you. When you're leaning, it's easy to stop listening. Okay? Look up. Look. A toenail only grows 13 millimeters a year. A fingernail grows 36.4 millimeters a year. If I made a graph, would you agree that the line would be positive?
Yeah.
Who would be more steep?
Fingernails.
Because they grow faster?
They go up
Yes.
faster.
Is this a direct variation?
Yes.
Because is it a proportional relationship?
Yes.
It is. All right, guys, we do have an exit ticket. Okay?
Bad day to skip math.
I recorded it, though. And we do have a quiz tomorrow.
Listening is